In this example, we have one of the applications of the exponential functions, and that is an interest problem. So the problem is, suppose that $268 is invested at 2.5% interest compounded quarterly. How much is in the account after 20 years? And round your answer to the nearest cent. So in looking through this problem, we need to figure out whether it's a compound interest problem or a continuous compound interest problem. There's two types in this class, and so if you look, nowhere in the problem do they mention the word continuous. So that's a clue that this is a compound interest problem. And then if you look at right here, they give you a value of quarterly. So basically 4 times a year that we're compounding. So this is definitely a compound interest problem as opposed to a continuous compound interest problem. Alright, so now that we've identified which type we're looking at, we know what the model that we're going to use is. And the formula A equals P times 1 plus R divided by N to the NT power. That's the formula for compound interest. So just to explain what the various parts are, it's important to know what they are and what they represent. So first, A, that's the amount in the account after T years. P is the principal that you invest. In other words, how much money you're putting into the investment. That's how much you start with. R is the annual interest rate that you're getting. N is the number of times that we're going to compound per year. And then T is the time, and that's measured in years. All right, so that's the model that we're going to be using for this particular problem. So it's always important in any kind of word problem to focus on what are they asking us for. So if you look through the problem, right, and the key part, what they're asking us to do is to find out how much is in the account. So going back to our model, you need to figure out which one of those variables that we're trying to find, and how much is in the account. Well, that's the amount in the account. So what we're after in this problem is the value for A. Okay, so somehow we should be able to figure out what the value for all the other variables in that model are for this particular problem. In other words, we need to figure out what P, R, N, and T are from what they state in the problem. And so, they might tell you that explicitly, or you might have to kind of figure those things out for yourself. In this particular problem, they pretty much come flat out and tell us what those values are. So going back to the model that we have, A equals P times 1 plus R divided by N to the NT power. If you look through the problem and get the values, they tell us that the principal, right, the amount invested is $268, so we substituted that in for P. They give us an annual interest rate of 2.5%, so change that to a decimal, right, and that goes in for R here. They tell us that the interest is compounded quarterly, so quarterly is 4 times a year. Alright, so we would put 4 in here and here, and then they tell us how much is in the account after 20 years, so they give us a time value of 20 years, so we would put that in for T. Okay, so we knew what the values of P, R, N, and T is, so it's just a matter of calculating out the value now that we have all the numbers in here. So you could directly plug this into your calculator, but there is one area that people tend to make mistakes on, and that is the exponent right here. If you're going to plug this into your calculator, I would recommend at the very least that you go ahead and multiply this value out. So in other words, just make this simplification right here. The problem is that people tend to put this exponent part, if it's not multiplied out, they forget to encase it in parentheses after the exponent symbol. And if you do that, it's going to only raise that quantity to the 4th power and not the 80th power. Okay? There's an order of operations issue there. So what I would recommend is that you just go ahead and multiply that out at the very least. If you have a graphing calculator, it's pretty easy to plug this into the graphing calculator and multiply that out. If you don't have a graphing calculator, if you're just using a basic scientific calculator, one area you'll probably want to be a little bit careful of if you do this step by step or piece by piece in the calculator. You don't want to round off too much on this inside part here, because that will affect your answer pretty drastically there. So if you can, just try and leave it like this. If you do round off this answer, this part in here, just make sure you take an extra few decimal places, and that will make sure that your answer is closer to the exact answer there. Alright, so when I plug this into the calculator and calculate that out, I get a value of $441.17. If you have questions about how to plug that into your calculator, or you're having trouble with that, just let me know and I'll try and post something up about that.